Hi, in this video we are going to look at the small signal gain of a differential amplifier. But this time around we are looking at it intuitively. So previously we mathematically proved that the small signal gain of the differential amplifier is equivalent to the half circuit gain of a single stage equivalent. So now let's do some analysis and some intuition here to prove what we discovered with the mathematical proof. Assuming the voltage Vin1 changes or goes up by an amount delta V, and per differential signals, for the differential output not to reject the change, then the Vin should go down by the same amount, not up. If they all go up, then the change will be rejected, as we have seen. So now the differential input 1 minus Vin2 is going to be delta going up minus the same delta going down, so that has to be 2 delta V. Okay, now to find our gain, all we need to do is find V out 1 minus V out 2. All right, so what happens when the signal changes by a small value delta? The V output at this node would be VCC minus IC, but the IC, we are going to break it into two parts: the bias collector current, in this case that is going to be the IEE over 2, plus the slight change in the collector current, and this slight change in the collector current is as a result of this, so change in IC1. Okay, now this can also prove something interesting here. Let's look at what happens at the other side. So for the output not to reject the changes in the input, they should be differential signals, and which means the output on the other side is going to see VCC minus, once again, IC2, which should be equal to IEE over 2 plus some small changes in times RC. Now, first thing we should notice is this change and this change should be such that the relationship IC1 plus IC2 is still equal to IEE. And that is only possible if the change in IC2 and the change in IC1 sums up to 0. So by that, we can conclude that if the voltage at the input goes up by a small change delta, then the current would also go up by a small change delta. And if the voltage goes down by a small change delta, then the current should go down by equal amounts delta IC2 for this relation to be satisfied. Okay, so now we can get the small signal output from the changes here. So what we recall from the common emitter stage is once the input goes up, the output should go down. So with that in mind, we can easily tell that if the input went up by delta, then the small signal output is going to go down by this relation here. Okay, so V in 1, V in 2, then over here I'll do V out 1 and I'll do V out 2. Okay, so V in went up by delta V, and the differential signal should be such that if the output wouldn't reject this change, then V in 2 will go down by the same delta V. We just realized that from the common emitter stage, if the voltage goes up, the output should come down, and the output would come down by the transconductance of the device times the change in the voltage. So this will be the current times, so as the current is going up, then the drop will increase. That means the output voltage will go down. So times the RC. So this is by how much the output will go down, because we know the common emitter stage, we have a negative gain, which shows 180 degrees phase shift between the input and the output. So we look at the input 2 at the other side, Q2, per differential signal, that one would have to go down by delta, else the change will be rejected at the output, and V2 would have to go up. Okay, so common emitter stage tells us that if the input is going down, then the output voltage would go up. So the difference is going to be the same GM because of symmetry. The two transistors Q1 and Q2 are the same, so they have the same transconductance, and we had the same change in voltage and RC for symmetry, so the voltage would increase. So if this is a voltage fall and this is a voltage rise, then when I do V out minus V2, V out 2, I expect to get twice of this, because I stand here and I move down, and I stand here and I move up. The difference between them is going to be 2 delta V. So I can conclude that V in 1 minus V in 2 is equal to 2 delta, and also V in out, V out 1 minus, so previously we called this Vx minus Vy, that's also fine, would be 2 GM. Okay, all right, so but once again, we know the common emitter stage, this has to be negative. We tried to avoid mathematics and wanted to use intuition more to get it, but the negative wouldn't go away. So finally, we can conclude that the output differential input over the differential output, so I meant the differential output, so differential output over differential input should be equal to the minus 2 GM there should be delta V over 2 delta V. This cancels that, this cancels that, and we conclude once again that the gain is equal to GM RC. Now, if you really don't understand why I put the negative here, it doesn't really matter. At this stage, you are not really interested in the direction or the phase shift. We just want to prove one thing, which has been proven mathematically already. We just wanted to intuitively also prove that the differential gain is equal to the single stage gain. Alright, so I hope you enjoy. Don't forget to like and subscribe to the channel. Bye.